right, so let's look at an alveoli. Alveoli. So let's draw this out. Okay, so let's look at, here's my trachea. Come down here and I'm going to become a bronchial, whatever, and eventually I go into the alveoli. So let's just look at a big giant alveoli. Okay, so the alveoli, and you should know this from AP1 and looking and doing the tissues. So the alveoli, the walls, I need a better color than that, I can see it. Okay, so the walls of the alveoli are made up of simple squamous epithelium. And you should know this. That should be a review. So if we make our little alveoli, so we make our little alveoli, and again, these are simple squamous cells, or squamous cells. It's one single layer. We know that's good because we know that simple squamous epithelium is good for filtration, absorption, and secretion. As we learned that last semester. So the simple squamous cells, and this is, you have to use your imagination here, but this is a sphere, not something flat. So think of this thing like a basketball. This is a round thing. So here, the whole, all the walls are just a huge layer or just a big sheet of squamous cells. All right, so these squamous cells actually are called type 1 cells. And type 1 cells make up about 95% of the cells that are in the alveoli, and again, these are the simple squamous cells of the walls. Okay, now there are other types of cells in here. So let's make one here. So put a cell here. So this cell is called a type 2 cell, and it's the other 5% of cells in the alveoli. And these cells are important. They do a couple of things, and one of the most important things they do is they secrete something called surfactant. And surfactant is a chemical that reduces surface tension. So that's another thing that you should remember from AP1. What was surface tension? Well, remember that the lung area, these areas are moist. We've humidified the air, and so there's water in there, okay? And if you remember, water looks kind of like this. So here's a water molecule, and remember, water is polar. So the oxygen is kind of negative and the hydrogens are kind of positive because oxygen is hogging the electrons. So that's why water is the way it is. It sticks together, and it sticks together through hydrogen bonds. Whoops, that was not right. Negative, whoops, hold on. Negative, and then here's my hydrogens. Here's another. And here's another. So you get the picture here. So this is how water sticks together. Man, I'm losing my mind on the positives. It's negative, right? So that's how water sticks together. The molecules stick together through these hydrogen bonds. Remember what hydrogen bonds are? Those are the little attractions between the hydrogen, the positive hydrogen, and the negative oxygen. Okay? So the surfactant breaks these bonds a little bit in order to decrease the amount of surface tension, because that stickiness, especially since the walls of the alveoli are so thin, I mean, they're just squamous cells. If the water stays together like that and has that surface tension, it will not allow the alveoli to inflate. So the alveoli will collapse. So the surfactant breaks some of those bonds so that the alveoli can inflate with the air that you breathe in. This is the problem with preemie babies. Preemie babies that are born before a certain number of weeks aren't secreting surfactant yet. So when they're born, they can't breathe because they can't inflate their alveoli. So pretty important. So that's the first thing that type 2 cells do. Another thing that type 2 cells do is they actively transport, so they actively transport solutes out of the alveoli, okay? And as it's doing that, what happens? So it's actively transporting out solutes, and what's going with it? Water's coming with it. Water follows the solute, right? So water is coming out as well, and which makes sense because we're breathing in, the air is being humidified, there is water accumulating in there because of that, and you wouldn't want it to fill up with water. So we need to get rid of some of that water as it comes through. Okay, so what else is in there? Well, there's also purple. There's also little macrophages in here. And the macrophages help to get rid of things that are coming in that microbes or pathogens and dirt and whatever else. Okay, so macrophages help to clean the area so that there's a good amount of air, clean surface area for gas exchange to occur. So what happens here? All right, well, of course, gas exchange. So we have oxygen, and oxygen is going to, remember, we have a bunch of capillaries that just surround these alveoli, the pulmonary capillaries. So the oxygen just diffuses through. Okay, diffuses from an area of high oxygen to an area of low oxygen. And remember, the blood that's coming back through the lungs is deoxygenated. It's already been used by the tissues. So it's going to be low oxygen. So that oxygen is going to diffuse readily across to its area of high to low. The CO2 is being carried in from the tissues, and so CO2 in the lung is going to be low, so the CO2 is going to diffuse into the alveoli. Okay, it's going to be high here, low there. It's just diffusion. Okay. So that's basically how gas exchange occurs here. These macrophages that keep things clean, if you're a smoker, what else is around these alveoli and around the tissue of the lung? The tissue of the lung has a lot of elastic connective tissue in it because it allows the lung to expand and recoil, bounce back after you exhale. So macrophages, as they're working and working, when they're overworking, they secrete elastase. So elastase is an enzyme that breaks down elastic connective tissue. So if the connective tissue is, or if the elastic connective tissue is breaking down, what's going to happen to the ability of the lungs to be able to snap back? It's going to lose that ability. So that creates something called emphysema. So these people that have emphysema, which comes from smoking, they can breathe in, but they can't breathe out. So they end up with a lot of air just stuck in their lungs, and that air is basically full of carbon dioxide. So very, very, very bad thing. You should not be smoking. Smoking is very bad for your lungs, obviously. And just looking at this, what we've looked at, the alveoli are really, really delicate. I mean, these are one cell layer thick. Okay. So that's just from smoking. Vaping isn't any better. Okay, so vaping has chemicals that are coming in here that macrophages have to deal with, and it also inundates the alveoli with extra water. Okay, so that's just more water that has to be gotten out so that the alveoli doesn't fill up. All right, so that is how the alveoli works. So let's look at the serous membranes.